Welcome to lab number 6. Today's experiment will be looking at a plate heat exchanger. We'll be running this experiment under two conditions. First, co-current, and second, countercurrent flow. The equipment used in this experiment is a PA Hilton heat exchange service unit. The main components on the equipment is the plate heat exchanger. A plate heat exchanger uses metal plates to transfer heat between two fluids. It consists of a series of parallel plates that are placed one above the other so as to allow the formation of a series of channels for the fluids to flow between them. Basically, the fluids is flowing against each other but separated by the metal plate. The inlet and outlet holes at the top and bottom corners of the plate allows hot and cold fluids through, so that a plate is always in contact on one side with the hot fluid and the other side with the cold fluid. Now, let's move on to the other components of the equipment. Next, we will be looking at the water supply, both hot and cold. The hot water supply comes from a heater reservoir from inside the unit. It is maintained and filled by adding water at this inlet. This hot water then cycles through the system continuously. Next, the cold water supply comes from a pipe tapping, so continuous flow of room temperature water enters the plate heater exchange, and the heated water is exited into the drain. Now, both hot and cold flow rates can be controlled by a rotometer. The flow on the rotometer are adjusted by rotating these knobs clockwise to decrease and anti-clockwise to increase. Next, we have the thermocouple switch that allows us to read the temperature at each inlet and outlet, which are notated as T1, T2, T3, and T4, which can be seen here. 1, 3, 2, 4. We would rotate this dial to read T1 temperatures, T2, T3, and T4 also. Above the thermocouple switch, we then have our digital display that shows us the actual temperature at the specific thermocouple, whether it's 1, 2, 3, or 4. Above, we have our display dial that shows us our preset temperature, that is 60 degrees, and the temperature in the green shows us the actual heater temperature. So we would wait until this section gets to 60 degrees for us to observe stabilization. Next we have our heater switch and main switch, which turns the machine on and off. We will be conducting this experiment in two different conditions. The plate heat exchanger will be in the co-current meaning the water flowing in the same direction. And also we'll do countercurrent, which is water flowing in the opposite direction. For each configuration, we will be observing T1 to T4 at different flow rates. We will have the hot flow constant at 40 gallons per second, and the cold flow will vary from 15 gallons per second to 20 to 25, 30, and 40 gallons per second. This will be done for both co-current and countercurrent. At this point, the machine is configured for co-current flow, where we have the hot water going in to the heat exchanger and it's coming down and exiting on the return line to the system. We have the cold water going into the plate heat exchanger, coming down and exiting to the sink. Now we are observing our actual water temperature, which is now 59, and our preset temperature is 60. So at this point we will observe equilibrium. At this point we are at equilibrium, so we can begin our first readings. Cold water set to 15 gallons per second, hot set to 40 gallons per second. Our T1 readings 61.4, T2 54.1, T3 24.5, and T4 45.6. Now we will adjust our flow to 20 gallons per second on the cold. And we'll give the system some time to stabilize back to equilibrium. Then we will proceed to observe T1 to T4 readings. T1 62.6, T2 53, T3 24.7, and T4 43.7. Now we'll adjust our flow rate to 25 gallons per second on the cold, keeping the hot constant at 40 gallons per second. And again, we'll wait for some steady state condition. Then we'll observe our T1 temperatures. T1 61.7, T2 51.4, T3 24, and T4 40.9. Now we'll adjust to 30 gallons per second on the cold. Allow for a steady state, then observe our T readings. T1 61.2, T2 49.6, T3 24.6, and T4 38.6. Now finally we'll take it up to 40 gallons per second on the cold flow. Allow for a steady state, then take T readings. T1 59.9, T2 47.9, T3 24.6, and T4 36.8. So at this point, our co-current readings are complete. So what we would do now is to change the flow direction for countercurrent. So first we would turn the flow off on the top. Then we would reorientate the flow by removing the flow coming in and removing the flow return to the top. And putting the flow in at the bottom. So now we're configured for counter current. As the hot flow will be going down, the cold flow will be going up. So now that we're configured for our counter current flow, we would turn the flow back on. Then we'd turn the machine back on. We would then wait for equilibrium to take place. So now that the system is configured for counter current flow, we would go ahead and take our readings with our hot water constant at 40 gallons per second, and our cold water will be varied from 15 to 20, 25, 30, and then 40 gallons per second. So let's begin. Hot water at 40, cold at 15, T1 reading 59.3, T2 50.8, T3 24.5, and T4 46.7. We would then adjust our cold flow to 20 gallons per second, allow for a steady state for equilibrium. Then we'll take our T readings, T1 59.6, T2 49.9, T3 24.5, and T4 44.8. We would then adjust our cold flow rate to 25 gallons per second, allow for some steady state condition. Then we would proceed to T readings. T1 59.6, T2 48.4, T3 24.4, and T4 41.5. We would then adjust our cold flow rate to 30 gallons per second, allow for some steady state of equilibrium. Then we would take T readings, T1 58.8, T2 47.1, and T3 24, and T4 39.1. Finally, we would take our flow up to 40 gallons per second, and of course allow for some steady state. Then we would observe our T readings. T1 58.2, T2 45.5, T3 24.5, and T4 36.1. So at this point, we would have gathered two sets of data, one in the co-current flow and the other counter-current flow, and we observed our T1 to T4 readings along with our heater readings. So at this point, the experiment is complete. Any questions, feel free to contact your professor, Dr. Whitworth. Thank you.